Assalamu alaikum. So the lesson today is about quadratic statement. So we are going to learn what is a quadratic statement and the type of quadratic statement that we know and the common concepts that those quadratic statements share together. So first, so let's define what is quadratic statement or quadratic expression. So definition. So quadratic statement is any degree 2 polynomial. So any degree 2 polynomial is a quadratic expression. So quadratic expression is any degree 2 polynomial. So defined by, so how we define the quadratic expression, defined by ax squared plus bx plus c, and of course a, b and c are number and a must be different than 0. So where a is not 0, b, c are number. So let me give you an example of quadratic expression. So 3x squared plus 5x plus 3, 2x squared minus 8x minus 11, 3x squared plus 5x minus 7x squared plus 11, 4x squared minus 13, minus 9x squared minus 2. So all those are example of quadratic expression, and there are more. So you have to remember, so this is just a remark. So the degree of any quadratic expression is always 2. So the degree of ax squared plus bx plus c is 2. This is the first remark. The second remark, the leading coefficient a of the quadratic expression never can be 0. So the leading coefficient a never equal 0. So those are the key of the quadratic expression. So the type of quadratic expression that we know, so the most used quadratic expression or statement are quadratic equations, quadratic function, quadratic inequality. So the most used quadratic statement so are, we have quadratic function, quadratic equations, and quadratic inequalities. those are the most used statements. So, but those statements they share common concept. So really they share one common concept, and that concept is called discriminant. So we cannot talk about any of those without talking about discriminant. So that's the common concept that they all share together. And what is a discriminant? Discriminant is just a number that tells us about the quadratic statement. It's like a diagnostic about the quadratic statement. So it's exactly what is the discriminant. So the common concept they use together is a discriminant. So what is discriminant is just a number. The discriminant is a number. The discriminant of ax squared plus bx plus c is a number defined by, so we always name d, so b squared minus 4ac. So I take the coefficient of x, make it square, minus 4 times the coefficient of x squared times c, which is the constant. For example, so if I want to find out the discriminant of 3x squared minus 4x plus 8, so like I say, d is b squared minus 4ac. So keep in mind b is the coefficient of x, always keep the sign. A is the coefficient of x squared, and c is the constant. So here I will have minus 4 square minus 4 times 3 times 8. So it's going to be 16 minus 12 times 8 is 96. So here will be minus 80. So let me give you another example. So if I have, for example, 2x squared minus 8x plus 4. So again, this is my A, this is my B, and this is my C. So my D will be B squared minus 4AC. So which means that I will have minus A squared minus 4 times 2 times C, which is 4. So it's going to be 64 minus 32, which is 32. Another example. So if I give me minus, you see here I'm going to flip the order. Minus 7x squared plus x. So keep in mind, if I don't have a value for x is 1, so this will be my C, this will be my A, and this will be my B. You see, keep in mind, C is always the constant that has no x next to it. C is the constant, B is the coefficient of x, and A is the coefficient of x squared. So look out for x squared, the coefficient next to it is A. If there is no coefficient, that means it's 1. B is the coefficient of x. So even the order is not the same, it's not like ax squared plus bx plus c, but keep in mind that A is the coefficient of x squared, B is the coefficient of x, and C is always the constant. So here to find out my discriminant, which is b squared minus 4ac. So my b is 1, so it's going to be 1 square minus 4 times what is my A. A is minus 7. What is my C is minus 5. So it's going to be 1 minus 140, which is minus 139. So the discriminant can be positive, can be negative, can be equal 0. So keep in mind this. So what are the case, or how can we use discriminant diagnostic the quadratic expression? So as you see, the discriminant is a number. So a number can be either positive, can be either negative, or can be equal to 0. So we have three choice. Either the discriminant is positive, or the discriminant is negative, or it can be 0. So what happen if it's equal 0? What happen if it's negative? What happen if it's positive? So those are the case we're gonna discuss here. So property, discriminant property. So so the first property, if the discriminant is less than 0. So what does it mean if our discriminant is less than 0? When discriminant is less than 0, which means that the sign of x squared plus bx plus c has the same sign as the leading coefficient. So if the discriminant is negative, then the sign of ax squared plus bx plus c is the same as the sign of the leading coefficient a. What does it mean? This means if a is positive, ax squared plus bx plus c will be positive for any value of x. So this means if a is positive, then ax squared plus bx plus c is positive for any x you pick. Any x you choose is going to be always positive. Let me give you an example in this. So if I choose, for example, x squared minus 2x plus 5. So if I do my discriminant, which is b squared minus 4 times ac, so like I say, this is 1, so this is my a, this is my b, and this is my c. So I will have minus 2 square minus 4 times 1 times 5, so it's going to be 4 minus 20, so this will be minus 16. So here a equal 1 and it's positive, so then I can say that x squared minus 2x plus 5 is always positive. You choose any x, you substitute the x here, is going to be always positive for whatever x you choose. How big is how small is going to be always positive. So the second case, if a is negative, then I will have ax squared plus bx plus c is going to be always negative, and this is again for any x. So let me give you an example for this. So let's pick, for example, minus 3x squared plus 2x minus 5. So the discriminant, like I say here, it's my A, this is my B, this is my C. So here I will have 2 square minus 4 times minus 3 minus 5. So 4 minus 60. So it's going to be minus 56. So it's negative. And the A here is equal to minus 3, which is negative. Therefore, I will have minus 3x squared plus 2x minus 5 is going to be always negative for any x you choose. Any value for x you choose, this statement will be always negative. So this is the case when the discriminant is negative. Just the sign of that quadratic expression is the same as the sign of the leading coefficient. So this is what tell us the discriminant for that case. If the discriminant is equal to 0, in that case the quadratic expression is a perfect square. Then ax squared plus bx plus c is a perfect square. So let me give you an example. So, so if I choose x squared plus 6x plus 9, so if I do my discriminant, so it's going to be b squared, which is minus 4 times 1 times 9, because a is 1, so which means that I will have 36 minus 36 equal 0. So this is a perfect square, and this is the same thing as x plus 3 square. As you see, this one is a perfect square. For example, if I have 4x squared plus 20x plus 25. So if I do my discriminant here, so it's going to be 20 square minus 4 times 4 times 25. So here is going to be 400 minus 4 times 25 is 100, times 4 is 400. So again 0. So this one is a perfect square. So I can say that 4x squared plus 20x plus 25. So it's the same thing as 2x plus 5 squared. So this is the case when it's equal 0. And when it's greater than 0, if the discriminant is greater than 0, then what happens is I have 2, 0 for that quadratic expression. That means there is two numbers that make that quadratic expression equal 0. So then there are two numbers called, so they have a name, those numbers called 0 of ax squared plus bx plus c, or the 0 of the quadratic. So what happened to those values? So they make the quadratic equal 0. So they make ax squared plus bx plus c equal 0. Equal 0. So for example, x squared minus 5x minus 14. So if I look for my discriminant, so this is my A, this is my B, and this is my C. So I will have minus 5 squared minus 4 times A, C. So it's 25 plus 56, which is 81. So this is greater than 0. So which means there are two numbers that make this one equal 0. So let me give you those two numbers. So if we choose x equal 7 and x equal minus 2, so if I substitute those numbers into the quadratic expression, it's become equal 0. So if I substitute, so it's going to be 7 squared minus 5 times 7 minus 14. So it's going to be 49 minus 35 minus 14. So it's going to be 49 minus 49. You see, it's become 0. So you see, 7 is 0 of that quadratic expression. If I plug in minus 2, I will have the same thing. So minus 5 times minus 2 minus 14. So it's going to be 4 plus 10 minus 14, which is 14 minus 14 equal 0. So this is the idea behind the quadratic statement and about the common concept they share together. So I hope you got the idea about this introduction, and please, if you have any comment that will improve my way of teaching, so do so. And thank you for watching the video, and Assalamu alaikum.